Hi class, Assalamualaikum and good day. For this week, we are still in chapter 5. Okay, chapter 5 chapter 5 we take it about 4 weeks. Okay, 4 weeks. Until the end of this semester. So now we are at the second week of chapter 5. Okay, so in this week, I will give you another topics that we will touch on is about the application. Okay, application of the PDE. Okay, application. So in this one, we will deal with two type of application. Okay, two type of application, which is heat equation. Okay, heat equation, and another one is wave equation. So later on I will show lah for that wave. So for now, in this video, I will explain or I will give you example on heat equation. So basically, the general for heat equation for heat. Okay, equation for heat. Du dt K, so K is a constant. D square U. So when every time you get this type of equation, means that this is heat equation. Okay. So the question here is, okay, example. Suppose that a rod length 40 cm is heated with initial temperature function is equal to Fx equal to x squared, and its two ends are embedded in ice at temperature 0. The boundary value problem for the equation is, so this is the equation and also the boundary condition BC and also IC. Okay. Alright. So class, the situation here is you have a rod. You have a satu batang besi, okay, rod, which is the length of the rod is 40 cm. So the length here we represent as x. Okay, so if you can see, this is the interval. So means that x here is represent the length of the rod. So the length, of course, let's start from 0 until 4 cm. So the length will be 4 cm. And then the rod is heated with initial temperature x squared. Okay, right? And its two ends are embedded in ice. Okay, just imagine that they have one rod and then the initial, the two ends. Okay, two ends means the hujung lah, this end. And this end is embedded ataupun dicelup ke apa ke, embedded in ice. Okay, in ice. So of course the temperature of ice is mentioned here is 0 lah. So it's as we consider that one is as a initial temperature lah. Okay. Sorry, not initial temperature. Initial temperature is given by this function. This is the two ends temperature, hujung ni dengan hujung ni punya suhu. And then the boundary value problem is given by this. Okay, so this is your heat equation. Okay, alright. And then this is the length of the rod. Okay, actually they have a you need to take it take it as important information lah, because from here actually you will know that the L. Okay, if you still remember this one, we will use Fourier series. So in the Fourier series, we need to have the L value. So you can get it or L from here. Okay, because the L here is the length, right? So length. Alright, so then this is what? Okay, so for this type of question, it doesn't state that which one is BC. BC is stand for boundary condition, and which one is IC. IC is initial condition. So they have two equations. They have not two. They have 1, 2, 3. So in the first row here, the second row here, U0t equal to U4t equal to 0. So this is what you call. This is a BC class. So this is a BC. You need to know which one is BC. Which one is IC. BC is fan boundary. Okay, boundary. Boundary is a border or sempadan. In Malay, we call it sempadan. So like we showed just now, this is a road. Okay, we have a road. So these two end, this is the what you call the border. Okay, this is the border, and these two end, hujung ni adalah sempadan ataupun border. So you can see that the x here is 0. Yes, x is 0 because this length start from 0. For example, here is 0. So at 0 and then it end with 4. Okay, because the length here is 4, right? So 0, 4. So this is the BC. Okay, you need to identify, you need to know which one is BC equation and which one is IC equation. So automatic, the another one is IC condition lah. Kenapa you kena tahu? Because they have a steps, whereas when you need to use BC and when is you need to use IC. So BC we use to find at early stage ataupun early step, and IC we find when we comes to the end, which is you need to find the BN and so on. Okay, that apply the Fourier series baru kita akan guna IC. Okay, so this is a question like that we want to solve it. Okay, so first of all, like I said, they have 3 steps, which is you need to show that this equation is separable, and then after that we need to solve the separated equation, and step number 3 is Fourier series. But when we get this type of equation, step number 2 tadi, automatically we just ignore, because step number 2 and step number 3 is equal, is it? Just for step number 2, we will use step number 2 when it doesn't given to you the BC. Bila tak bagi BC and IC, yes, you will use step number 2. Because when you didn't have the value or the information regarding the BC and IC, so you don't have to find the value of A, B, C ataupun every unknown that appear in the equation. But now it's already given you BC and IC, so therefore you will I can say that we just jump from step 1, which is after you show that it is separable, then you show and then you proceed to step number 3, Fourier series. Okay, alright. So basically this example is similar like the previous I mean the last week punya content. Just this one is give you in term of application. Dia bagi, I mean it's give you in some situation here, which is it's a heated road. Okay, heat equation, so dia bagi example of heated road. Okay, and later on another type of equation, so maybe the different situation lah. Okay, so the step 1 here we will show that this equation is separable. So of course dia memang akan separable. Okay, so this is the equation. So you will apply what? You will replace with x t prime, and then equal to x double prime t. Is it? Okay, then divide by x t, right? So this one can cancel, this one can cancel, so they have t prime over t equal to x double prime over x. Okay, so you can see this is a separable. Of course lah, separable because of in the one side you just have a t equation, and on the other side we just have a x equation, so this is separable. So before we go to step number 3, just rewrite again here. So this equation is equal to k, right? K. So means that they have 2 equations, which is x double prime over x equal to k and t prime over t equal to k. So now we will use this equation, okay, to step number 3. Okay, step number 3 is Fourier series solution. Okay, so you need to do it one by one cases. So we just we start with case 1. Case 1, which is k equal to positive, right? K positive, so which is k equal to lambda square. So we will start with the complex one. Equation complex here, it means that you see the order. So the x equation is the second order, is it? So you start with x equation first, and usually yes, we will start with x equation. And this equation is to the lambda square, and then x double prime minus lambda square x equal to 0, m square minus lambda square. Okay, basically the same. I mean, bukan saya nak cakap it has a own difficulties. Dia ada tahap kesukaran dia sendiri untuk soalan PDE ni, but basically the steps will be equal. Macam ni, okay, you already you already faced this equation a few times, really. When you have x double prime so on and equal, because it's already fixed, dia dah fixed pun equal to lambda square and then equal to 0 and then equal to negative. So the step will be repeated when you do it again. That's what I mean. If you keep doing the exercise, even though it's the same question, it will help you a lot. Sebab dia punya step sama, cuma of course lah dia punya beza dia ataupun the different here is when you apply the BC and also IC. And also maybe if they have a constant here, So it will be different. What I have to say here, this step will be equal. This step will be equal. Okay, so like this, you already face it, or you already familiar with this equation, right? M square minus lambda square. If you done, or if you do the, or if you watch the previous video, so I think you will feel that oh, baru buat ni tadi. Okay, because it's similar. Okay, so m square minus m square minus ni, so means that m square equal to lambda square. Therefore, your m is equal to plus minus lambda. So it's a real and this thing, right? So then the x equation is equal to not c1, yeah, c1 e lambda x, and then plus c2 e negative lambda x. Okay, then what you should do now is you need to apply your BC. Okay, your BC have two, right? You have two BC. So the first one is u0t, and this is equal to 0. Okay, so what you do is just substitute 0 into x, because this is a value for x. So x0 means that you have c1 plus c2. Okay, you substitute 0. Okay, substitute 0 not means all 0. When you substitute 0 here, it will be e power of 0. Okay, e power of 0. Okay, when lambda times 0 equal to 0, and then e power of 0 is equal to 1. So therefore, you left with c1. Same goes to c2, right? Then the second BC is u4t. Okay, so this is the first equation just now. Okay, so now the second BC is 40. So you repeat the same thing, but now you will substitute 4 into x. C1 E 4 lambda, 4 lambda plus C2 E negative 4 lambda, and this equation also equal to 0. Okay, so now our objective is to find the value of C1 and C2. So you have two equations and you have two unknown. So you will use the substitution or you will use simultaneous. But I prefer substitution lah, because kalau simultaneous dia tak same level, because this is they have no exponential, this is have exponential. So nak buat simultaneous is not too suitable lah for this type. So you use a substitution. So I take it the equation 1. So I will let C1 equal to negative C2. So this is I let as my equation 3. Okay, so what I will do is I will substitute equation 3 here. I will substitute equation 3 into equation 2. Okay, so C1 now I will replace with negative C2. Okay, I substitute C3 into C2. Equation 3 into equation 2. Okay, then C2, okay, I factorize C2. Okay, I left with inside here negative 4 lambda, negative exponential 4 lambda plus E ataupun exponential negative 4 lambda. Okay, just now is positive. Okay, positive, negative. So I want to have C2 class. So what we do is we just bring this all to this side. So we get C2 equal to 0. Then, okay, let's say I give you this one is equation 4. So then what we do? Substitute equation 4 here into equation 1 again. So you will get C1 also equal to 0. Therefore, we omit the case. Okay, we omit the case. Yeah, and like I said before in the previous video, I said that yes, of course, usually, but not usually lah, memang of course lah. Case 1 and case 2 actually memang kosong. We omit, but you still need to show it. Okay, you still need to show it. So when we omit the cases for S, automatically you no need to do the for equation T. Okay, tak perlu buat equation T. So now we go to case number 2. Okay, case number 2 is when K is 0. Okay, so when K is 0, okay, we start with S juga. Okay, then this one S double prime equal to 0. So M square equal to 0. So M equal to plus minus 0. Okay, class, even though it's plus minus 0, we keep repeating this. Okay, when it, please careful kan. Walaupun dia plus minus kosong, dia akan dapat kosong juga. Yes, but you need to consider this one is two value of 0. So which this one is real and repeated lah. Okay, real and repeated. So therefore the X equation now will be C1, C2, C3. C3 E 0x, okay, I just write it first, okay, and then plus C4x, okay, E0x. So we have C3 plus C4x. Alright, so now we apply the same BC. The first one is U0t equal to 0, so therefore the x equation now equal to C3 equal to 0. And then the second BC is U4t equal to 0, so therefore x4 equal to C3 plus 4C4 equal to 0, and just now you already have the C3 is 0, so therefore you just left at 4C4 0, and to get C4 you just bring to 4 to the side, so C4 also give 0, so therefore you will omit this case. Okay, sebab C3 kosong, C4 kosong, then after you substitute into x, you will get x0, so therefore you no need to find the t equation. So now we come to, or we just proceed to case number 3, and case number 3 cannot be equal to 0, okay class, even though if you get the C5 ke C6 ke later on, if you get a 0, you still need to make it an adjustment like I showed you in the previous video, which is you need to find out the value of lambda. So you will apply the same thing. So that's what I mean, is the procedure, the step will be equal, sama je untuk soalan-soalan lain pun. Okay, so case number 3, okay, x double prime over x equal to negative lambda square, so therefore x double prime plus lambda square x equal to 0, m square plus lambda square equal to 0, m square equal to negative lambda square, m equal to plus minus square root lambda, so therefore plus minus lambda I. Okay, plus minus lambda I. So your x equation now tadi C4, C5. So C5, they have, in front of they have e cos something, right? E power of ax, but our a is 0, so therefore I didn't write a, I just proceed to the next one. C5 cos lambda x plus C6 sin lambda x. Okay, then the BC that you have just now, Z0t to 0, so just substitute 0 here into x, so therefore you have C5, C6 0 is 0, so therefore you have C5 equal to 0. And then the second BC is U4t equal to 0, so U4t means that C5 cos 4 lambda plus C6 sin 4 lambda equal to 0, and we know that C5 is already equal to 0, so habis. Then you left with C6 sin 4 lambda equal to 0, and class, please, C6 cannot be equal to 0. Okay, now C6 cannot be equal to 0. So what we equal to 0? Sin 4 lambda. Okay, sin 4 lambda yang akan sama dengan kosong. Okay, so we want to find lambda, so for okay, so yang saya ajar last week, they have, because lambda, it can be not just one number. Lambda can be more than one, and until infinity. So what we do, okay, I'm just because this is this one it's not try and error, but yeah, it's just try. So what we do is you need to calculate, try a few numbers. For example, like I said, that sine and cos is in degree, okay, in the degree. So degree means that we have a 45 degree, we have a 90 degree, we have 180, we have 360, and so on, 540 to 70, and so on, but in terms of degree. So we will try to calculate, for example here, sine 4 lambda, because we want to find the lambda value, or we want to find 4 lambda lah, 4 lambda, okay. So sine, we try sine 0, imagine that 4 lambda is 0, sine 0, sine 0, okay, so you have 0, yes. So the first value can be 0, okay, means that 4 lambda can be 0, okay, maksudnya macam ni, bila you tekan sine, apa, number apa yang you nak gantikan dekat 4 lambda ni, so you try and error. So I try with the 0 first, so I tried sine 0, so sine 0, yes, I get 0, so therefore my 4 lambda can be 0 lah. This is the first value that I can get. And then we try another one, sine tadi 0, so maybe you want to try, kita ambil 90, sine 90 is equal to 1. So means that 90, or okay, 90 is equal to pi over 2 and class. So we are using this term, okay, pi and so on. Kita takkan tulis macam ni, alright? So when I try sine 90, the answer is 1. But we want to get what the value that we calculate sin value apa tu dapat kosong. So kita this one I show that sin 90 is equal to 1. Therefore 90 is not the answer in this. Okay, 90 ataupun pi over 2 is not the answer one. Not the answer here lah. So we try sin 180 pula. Yes, sin 180 is 0. So 180 is equal to pi. Okay, then we try sin 270 270. Okay, 270 is equal to negative 1. So therefore 270 ataupun 3 over 2 pi is not suitable for this one. Okay, because it's equal to negative 1. We want to get the number 0. When you calculate, you get 0. Okay, you get 0. So we try sin 300 0. So means that is 2 pi lah. Okay, we try another one value. Okay, it's already okay kalau you dah dapat 3, tapi we want to make it another one. Okay, to confirm the pattern, So 360 plus 90 we had 450 kan. So sin 450 is equal to 1. So it's not available, it's not eligible to this. Okay, lagi 360, 160, 10, 14. Okay, 540. Yes, equal to 1. So 540, if you convert it into pi, it will equal to 3 pi. Okay, betul tak? 3 darab 180. Yes, 540. So dot. Alright, so class, you can see that the pattern here 0, pi, 2 over 5, 3 pi, dot. Okay, what can you see here? Okay, before that, we just want to have pi, so you need to bring this 4 to this side. So you will have something like this lah. Okay. Okay, so we see the pattern now. Okay, tengok pattern dia. Okay, this start from 0, and then it's repeat. It's pi over 4, 2 pi over 4, 3 over 4. So 4 down here is fixed already, and then pi already fixed also. Okay, semua ada pi kecuali this one lah, tak apa. Jadi kita anggap dia tak ada ataupun is 0 pi. Okay, kita boleh anggap dia 0 pi lah ataupun kosong. Okay, but now you can see is the ascending order. It start from 0 and then 1, 2, 3, and it will repeat or it will extend to 4, 5, 6. If you don't believe it, you can try. Okay, you can try. But the pattern here will be just follow the ascending order, which is 0, 1, 2, 3, 4 something. So we just let as n. So means that n is from 0, 1, 2, dot. Okay, tak payah kosong pun tak apa kot. Saya rasa sebab kosong tu memang tak ada. So we just write 4 ataupun 1, 2, 3. So 1, 2, 3, 4, 5 until infinity is a number. So we it's just a number. Dia bukan, it's number that both can be even, can be odd. So we just let as n. Kalau dia even, kita akan let dia as 2n. Kalau dia even, 2n. Kalau odd, we let 2n minus 1. But now it's a number, only number. Maksudnya it can be any number. Can be positive, can be negative. Not positive. Can be even, can be odd. So we just let as n. So therefore, this is your lambda equation ataupun lambda value lah. So what next? Okay, next. Okay, from here, start from your x equation. So now your x equation now. Okay, C5 nothing, memang tak ada, kosong. So now C6. Yes, this is we still have C6. Okay, we just imagine that C6 is not equal to 0. Okay, then sin for lambda. So lambda here you need to replace with this. So it will be n pi over 4. Okay, 4. Sorry, not 4, lambda. Sorry, C6 sin lambda. Lambda tadi pula gantikan dengan n pi over 4x. Okay, so your x equation now is this one. Okay, but we need to, because we have the n here, so we need to write in Cn. N here represent is it can be any number of n lah. Okay, dia akan dapat a set of dia. So sin n pi over 4x, and then your n here is 1, 2, 3, dot, dot, dot. Okay, so we are done for x equation. So now we can proceed with t equation. So t prime over t equal to negative lambda square. So t prime plus lambda square equal to t equal to 0, t prime, m equal to m plus lambda square equal to 0, m equal to negative lambda square. Therefore, the t equation is equal to tadi C6, so C7 or D. We use D, okay, D E negative lambda square T, okay, and then, okay, we write Tn because of what? Because of the lambda now we will replace with n pi over 4 square as well. Okay, kita akan ganti every time you have a lambda, please make sure you already replace. Okay, you kena replace dengan lambda yang baru ni lah. Okay, so if I simplify this one, I will get negative n square pi square over 16 over 16 class. If you open this one, 4 times or 4 power 2 will be 16. Okay, and n equal to 1, 2, 3, dot, dot, dot. Okay, so this is t equation, this is x equation. So you need to substitute into your xt equation. So your x equation is cn sine n pi over 4x, okay, times with d and e negative n square over 16t. Okay, and n is 1, 2, 3, 4. Okay, so another one that we need to do is, okay, you can see that you have two unknown here, cn and dn. So I will replace bn equal to dn times cn. So I will replace, okay, because it's multiplication, right? So you can multiply. So we just assume that when we multiply cn and dn, it will give you another one more number lah, a new number. So I just let as bn. Okay, we let as bn. So we have, okay, I just rearrange. Okay, yang lain tu saya susun balik je. Saya cuma gantikan cn dengan dn je. Okay, so this one 16 over t. Okay, sama je. Saya copy balik, saya letak kat depan. And then sine n pi over 4x. And n equal to 1, 2, 3. Okay, and then you need to, instead of we write this one, we will write in terms of this summation. Okay, now it's no longer n 1, 2, 3. We already put it in terms of summation here. And then b n e negative n square pi square t over 16 sine n pi over 4x. So this is your uxt equation. So our objective now next is to find the value of bn. So to find the value of bn, you need to apply the BC, to apply the IC first, your initial condition. What is your initial condition just now? So your initial condition is u at 0 x square class. Okay, so what we do is, you have this one, okay, this is uxt, this is equation of uxt, and then summation, and then bn. Okay, so you will replace t with 0. Okay, t with 0. So e negative n square pi square t with 0. So therefore what you have here, 0 times everything is 0. So e power 0 is equal to 1. So therefore you left with only bn sine n pi over 4x. Okay, you only left with this. So now we find your bn. Okay, so yeah, bn. So bn is 2 over L 0 L fx sine, okay, sine n pi over 4x. Okay, you need to follow this one. So what is your L class? I already explained in the first, at the early stage, at the early video just now. Whereas you can get your L from the interval. So your L here is 4. Okay, 0, 4. And then what is your fx? Your fx here, you can get it from this question or from here. Either one. Bukan either one. Maksudnya these two is the same meaning lah. Okay. Okay, because it said that initial, right? Initial temperature. Yes. I is stand for initial. So x square. So x square sine n pi over 4x. Okay, so you need to solve it by using tabular method. Okay, so you have d and I here. So x square and sine n pi over 4x. So 2x to 0. 2x. Okay. Then plus minus. So this one, integrate sign, you will get negative cos. Cos n pi over 4x negative. And then this one, differentiate, you will get n pi over 4 over n pi over 4. So dia macam tak cantik kan? Kalau for me is look like messy sebab dia ada layer-layer. So I will convert it. Sin n pi over 4x. So I will convert it become negative cos n pi over 4x. Okay, times. Okay, I will bring it to up. Okay, saya akan buat ni atas. So dia akan jadi 4 over. Okay, dia akan jadi 4 over. Negative 4 over. Okay, negatif tadi lah yang tadi tu. Negatif tu yang tadi. Okay, so negatif ni kat sini. So negative 4 over n pi. Okay, it will become like this. Okay. Alright, so if you integrate again, okay, it will become sin n pi over 4x. And still, you repeat, you will still over, you will over n pi over 4. Okay, you will over n pi. So n pi over 4 just now, I will also bring to this side. So I will have negative 16 over n square pi square. And then the last one is cos n pi over 4. And then again you will have over n pi over 4. So I will bring it to upstart. So it will be positive. So now it will become positive. Times 4, 32. 64. 64 over n cube pi cube. Okay, and then you cross multiply lah for each sheet. So and then plus minus. So you substitute into this equation. Okay, cancel lah. This one 1 over 2. You will get, okay, 32 over n pi negative 1 power n plus 1 plus 64. I just copy from the slide yang ni okay, and then negative 1 this one. Okay, so all this you get it from here actually. Okay, alright. So this is your Bn. So the last one is substitute back into the equation of this one. Mana? This one. Yang ni, yang original yang you didn't substitute any number. I mean this is still T lah. So n1 infinity Bn. Okay, Bn you salin balik 32 over n pi negative 1 n plus 1 plus 64 n cube, is it? n cube pi cube negative 1 power of n minus 1. Okay, this is your Bn. And then they have E situ. Okay, tulis balik lah. Okay, put the bracket lah kalau tak nak ni. So E negative n square pi square T over 16. And then sin n pi over 4x. Okay, so this is your answer. Okay. Alright guys, so we stop here. So yeah, this is about the heated equation.